For today's notes, you will need your in-class 55 sheet. This is part 2 of standard 13. And you will also need a calculator that has the ability to find sine, cosine, and tangent if you're going to follow along. So the calculators that most of you own will do that. If you have this type of a calculator, no matter what the color of it is, your sine, cosine, and tangent buttons, I was trying to get that glare out of the way, are right here in the second row up from your numbers. So sine, cosine, tangent, right there along the middle. You do need to make sure that your calculator is in degree mode. So this says DEG in tiny little letters right there on the screen. If it's not in degree mode, you'll press this button right here next to button, DRG. That stands for degrees, radians, and gradians, and you'll make sure degrees is underlined and click enter. That should put the little DEG symbol on your screen. Another option that you might have might look like this, probably not bright yellow if you have it at home because that's the school color. Same thing, 2 rows above your numbers, sine, cosine, and tangent buttons are there, and then same thing on your screen. It's super tiny, but there's the little DEG. If you don't see DEG for degrees on this calculator, you'll press the mode button, and then that first row, you need degrees to be highlighted. So if it's not, if one of these others is highlighted, you'll just arrow and click enter so that it's on top of degrees, and then you can do second mode to quit out of that menu. It's very important before you do any of these problems that you always check your mode, because if it doesn't say degrees, it's going to give you the wrong answer for every single problem. If you have a graphing calculator, let me grab one of those. You have the same buttons available on a graphing calculator. They're still located 2 rows above those number keys, sine, cosine, tangent. Your menu is very similar to the yellow calculators. You'll click mode, and then inside there you'll make sure that you have degrees highlighted. This calculator is dead, so I can't show you, but I don't think very many of you probably have graphing calculators, but that's how you would get yourself in the right mode on that one as well. All right, if you do not have your own calculator, you're going to need one to be able to do your homework. So there are some really good calculators out there on the internet that you can use or that you can download as an app onto your cell phone. I'll put a link in the description to what I think is the best one because it operates the same way the handheld calculators that you can borrow during your tests operate. Okay, so you can check out the link in the description for this video if you're looking for a calculator that you could use on the internet to help you out. All right, we have the same information up top that we had in our intro note in class 54. It reminds us that sine of an angle is equal to the ratio of the opposite side over the hypotenuse. Cosine of an angle is equal to the adjacent side over the hypotenuse. And then tangent of an angle is equal to the opposite side over the adjacent side. We're going to actually learn how to use these to solve problems today rather than just identify vocabulary words and make sure we understand them. So our goal is to solve for each side that's missing, labeled with an X, and we are rounding officially, so we'll talk about what it means to round all of our final answers to 2 decimal places as we go. So we're not looking for exact simplified form like we have in the past. We're looking for rounded answers to 2 decimal places. All right, first things first, we're going to remember to label based on the reference angle. So the reference angle is the acute angle we've been given to use for the problem. That's actually going to be the theta in whatever equation we pick to use. Theta is the reference angle. So based on this reference angle, if I'm traveling to that X, I've got to go over to the opposite side. So that's going to be the opposite. And then the 21 is next to that angle, but more importantly, it's across from the 90. So that makes it the hypotenuse. If we look through our options, we want to pick one that uses the opposite and the hypotenuse. So that's going to be this first one, sine theta equals opposite over hypotenuse. So what we do is we fill in everything we know. Sine of theta, remember, is the reference angle. So that becomes a 28. Is going to equal the fraction or the ratio of the opposite side, x, over the hypotenuse, 21. And then our goal, as with all equations, is to solve for the x. So if I'm looking at this equation, I see x divided by a number. That means I need to multiply both sides of the equation by 21 in order to isolate that x and get it to be by itself. Notice that I wrote that multiplication out in front of the sign. We're not multiplying the angle by 21. We're multiplying this whole expression by 21. So we don't want to multiply the 28. We want to multiply that whole string by 21. That means that we're going to have 21 sine 28 equal to x, which indicates we should head to a calculator because your brain definitely cannot tell me what 21 sine 28 is. Type the 21 in first. If you want to type the multiplication symbol in, you can, or you can just click the sine command right away. That parentheses opens up to tell us that it's ready for our angle. That's 28. You can close it or not close it. That's up to you. Click, click enter, and that's going to be our answer. However, we're asked to round to 2 decimal places. That means we want to leave 2 numbers after the decimal point in our answer, but that requires us to look at the third number to decide whether this stays a 5 or rounds up to be a 6. Rounding rules say that if this third number is a 5 or larger, so 5, 6, 7, 8, or 9, then we round up our second decimal place to the next number. So this will round up to be 9.86. That's going to be our x value. You'll notice that our equal sign is squiggly. That's because this is not exactly what x is equal to. It's approximately what x is equal to. That's what happens when we're rounding. We don't get an exact answer. We just get a really close answer to what our x is equal to. All right, let's see what we can do on this next one. Start with your reference angle. The goal is to label the sides that have information provided. So we're going over to the opposite side to get to the x. So that's the O. This is right next to the 41, but it's not across from the 90, which means it's the adjacent side. I can't use sine if it's opposite with adjacent. I can't use cosine if it's opposite with adjacent, but I can use tangent. Opposite and adjacent will both have a place. So this equation is going to look like tangent of theta is 41 degrees. So that's going to replace the theta. And then that's equal to the ratio of opposite side over adjacent side. Again, we have our x sitting here being divided by a number. So we're going to multiply on both sides by that number. That's going to give us the x isolated by itself. And we'll have 11 tangent 41 to plug into our calculator. I'll use this calculator this time just so that it looks like what you're used to if you have this one. So we've got 11 tangent of 41, looks the same as it did before. Click enter, and we're going to do the same process. We're going to round, so we want to make sure we're looking at that third decimal place. That's a 2. That 2 means that we're not going to round up, so we're just going to leave this second decimal place as it is, 9.56. 9.56. And I just noticed while I was doing that problem that these both have centimeters on them as units, so we should have centimeters on our answer as the units for that answer as well. All right, on to example C here. 53 degrees this time for our reference angle. We do not know the side that's over on the other side of the shape, so opposite is missing. These are both next to 53, but 30 is across from the 90 degrees, so that's our hypotenuse, which means x is our adjacent. If we are missing the opposite side, we can't use sine and we can't use tangent, so this will be a cosine equation. Cosine of theta turns into 53 there next to cosine, and that's going to be equal to the ratio of adjacent, x, over hypotenuse, 30. We have division here happening again, so we're going to multiply both sides by 30 to isolate that x, which means that 30 cosine 53 is going to go to my calculator and tell me what my x is equal to. So we've got 30 cosine 53. We're going to look at that third digit again. This time that's a 4. So that tells me I do not round up. 18.05 will be my answer, rounded to 2 decimal places with our centimeter units attached. All right, onward we go. Let's see if something different happens down here in row 2. You can still see your equations up top. You won't be able to see them on the screen, but you can see them on your paper. Our reference angle is 32. Over on the opposite side of the triangle, we've got a 24, so that gets an O. This side is next to the 62, but it's not across from 90, so that means it's not the hypotenuse, it's the adjacent. Opposite and adjacent show up in the tangent equation. So we're going to have tangent of 62 for theta equals the ratio of opposite over adjacent. All right, this one is different because the variable is in the denominator, stuck in the bottom of the fraction. That is not a good place for a variable to be. So we can solve this equation 2 different ways. First, I'll show you method number 1, and then when we do it the next problem, I'll show you the second method, and then you can decide which one you prefer, and you can practice other equations that look like this in the way that you choose. Option number 1 is we get this x out of the denominator by multiplying by it. So we're going to multiply both sides by the x, which is going to move it to the left side of our equation. So this x is now multiplied by the tangent of 62, and the 24 is left on its own over here on the right. Now that does not give us something we can type into our calculator yet because the x is not by itself. It's multiplied by something. So round 2 here, we need to get rid of multiplication by using division. But that whole entire tangent of 62 needs to be removed. And so we divide by that entire command, that entire function, tangent 62, moves together to the other side, which means x is equal to a fraction, 24 over tangent 62. So we're going to go to our calculator, and instead of typing it as, sorry, there's that glare there I'm trying to avoid. Instead of typing as a multiplication, we're going to type it as division. So 24 divided by tangent 62 is what that will look like on this calculator. We click enter, and then we do the same thing. We look at that third decimal place. It's a 1, which means I don't need to round up, so I'm going to leave this as is. 12.76 will give me my approximate answer for x and attach our units of centimeters. Okay, so that's one way of solving for x when x is in the denominator. Let's see if that happens again in the next one, and if it does, I'll show you another option, see if you like it better. Our reference angle here on example E is 34 degrees. We do not have the opposite side over on the other side of the triangle, so we have the 2 connected to 34. The x is going to be the hypotenuse, since it's across from 90, and then 18 will be the adjacent side. When we have the adjacent and the hypotenuse, we need to write a cosine equation. So cosine of theta will be cosine of 34, the angle, and that's equal to the ratio of the adjacent on top and the hypotenuse on the bottom. So we do have another case where we are dividing by x. X is in the denominator of that fraction. So here's another way to think about how you could solve for x. Turn this equation into a proportion. So that means we need a fraction on both sides of the equation. Anything can be turned into a fraction by dividing it by 1. So I'm just going to set up a little divided by 1 underneath cosine of 34. And the nice thing about proportions is then we can cross multiply. So we can take 1 times 18, that's just 18, and set it equal then to x times cosine 34. So it's another way of eliminating the fraction and creating an equation where the x is now in the numerator because those fractions are gone. We still have to get x by itself with division, so we're still going to have to divide, this time by cosine of 34, which means we're still going to type a division problem into our calculator. X equals 18, we'll use the other calculator this time, 18 divided by cosine of 34. And we'll round just like we have been. Looking at that third digit, it's a 1, so that means we're going to leave that second digit as it is, and 21.71 centimeters will be our rounded answer for x. So they're very similar. It's just a different way of thinking about how to get that fraction to go away, or how to get that x out of the denominator and into the numerator. Either multiply on both sides by x, or think about it as a proportion and then cross multiply it. You choose which one you prefer. All right, on to the last example for this page. We've got a reference angle of 28 degrees. Over on the other side of that triangle, we've got the opposite side as 13. X is across from the 90, so that means it's the hypotenuse. When we have the opposite and the hypotenuse available, that means sine is going to be our choice. Remember, sine of theta means sine of the reference angle. So 28 sits next to that sine, and then that's equal to the ratio of opposite over hypotenuse. This gives me another opportunity to get that x out of the denominator, so I'm going to use the multiply by x method on both sides. That means x times the sine of 28 equals 13. So to isolate that x, I need to divide both sides by the sine of 28. X will be a division problem for the third time in a row. So on our calculator, we're going to do 13 divided by sine of 28. 13 divided by sine of 28. Type it all in carefully. And then always looking at that third digit, it's a 0, so that means no rounding up. 27.69 centimeters for our rounded answer for x. All right. We have one more set of examples on the back side of this page, so if you want to flip over to the back side and meet me there. This would be a great opportunity if you feel like you're understanding what's going on to pause the video and try these, and then come back and check your answers. Otherwise, let's keep rolling. We've got a reference angle of 33, so the x is on the opposite side of the shape, and the 23 is the hypotenuse. When opposite and hypotenuse are involved, sine should be your choice. We're going to do sine of 33 equals the ratio of opposite over hypotenuse. The x is in the numerator, so I can isolate it by just multiplying both sides by 23, which means I'm going to my calculator with a multiplication problem this time. 23 times the sine of 33 is going to give me 12.526. That 6 in the third slot tells me that that 2 needs to round up. So 12.53 will be my rounded answer for x. Still centimeters as our units. Reference angle on the next one is 48. 12 is over on the other side of the shape, which makes it the opposite. X is right next to 48, but not across from the 90, so it's the adjacent, not the hypotenuse. If I've got opposite and adjacent available, this is a tangent equation to write. So tangent of 48 equals the ratio of opposite over adjacent. My x is stuck in the bottom again, so I'll do this one with the cross multiply method in case that's your preferred choice. Put that tangent 48 over 1 so that we can cross multiply. We'll get 12 for one cross product, and x times the tangent of 48 for the other, which means we need to get rid of that tangent 48 by dividing both sides by tangent 48. We're going to go to our calculator with this division problem. So we're going to do 12 divided by tangent 48. Take a quick peek at that third digit. A 4 does not require me to round up, so we're going to end up with 10.80 centimeters as our rounded answer for x. Reference angle of 43 moves to the top for example C. We do not have the opposite side on the other side of the triangle, but we do have the hypotenuse across from 90 and the adjacent right next to the reference angle. Adjacent and hypotenuse cause me to pick cosine for my equation, which means the ratio is adjacent over hypotenuse. X divided by 15 can be isolated by just multiplying both sides by the 15. So I've got my x by itself now, which means I'm ready to calculate. 15 times cosine of 43 gives me a 10.970. 0 does not tell me to round up, so 10.97 centimeters. All right, 3 to go. The reference angle stays at the top this time, 50 degrees. Over on the other opposite side of the triangle is x, and across from the 90 is 8. So I've got opposite and hypotenuse. That matches up with my sine ratio. So sine of the reference angle 50 equals the ratio of opposite x over hypotenuse 8. We can get the x isolated by multiplying both sides by 8, which means my calculator is going to do 8 times the sine of 50. That's going to respond with 6.128. 8 tells me to round that 2 up, so 6.13 centimeters as my rounded answer for x. 2 to go. Reference angle of 23. Over on the opposite side is the 8. The x is right next to, but not across from 90, so not the hypotenuse, but the adjacent. Adjacent and opposite belong in a tangent equation. So tangent of the reference angle 23 equals opposite side over adjacent. Make sure you're careful that you follow the order when you fill in that fraction. That x is in the bottom, so we need to multiply it over or cross multiply it. That gives us x times tangent 23 equal to 8. So in order to get the x by itself, I have to follow that up with some division to move that tangent 23 to the other side of the equation, which means my calculator is headed for division mode. 8 divided by tangent 23 gives me 18.846. That third digit 6 tells me to round that 4 up, so 18.85 centimeters will be my rounded answer for x. All right, final example. We've got a reference angle of 33, nothing over on the opposite side, but across from the 90, we've got the hypotenuse, and right next to the reference angle, we've got the adjacent. Those two sides send me towards a cosine equation, so we fill in our reference angle, we fill in the adjacent over the hypotenuse. One more time, that x was in the bottom, so cross multiplying will help me to get the x out of the bottom of the fraction, and then we can divide both sides by cosine of 33 to figure out what x is. So we've got 6 divided by cosine of 33 going into the calculator. We take a look at that third digit. 4 does not require rounding up, so 7.15 centimeters will be my last final answer for that missing side. All right, to get us ready for a few days down the road, we do have a little review of some vocabulary from our last thing. Angle of elevation, remember, is from a horizontal up. So it might look like that, or it might be a horizontal up this way, so it could look like that. So the key is we're looking in this picture for some kind of horizontal. We've got 2 options, but then an angle that's going up from that horizontal. If I look up here, there's nothing above that horizontal, but down here, right there, we've got angle S, or angle LST. That would be an angle of elevation in this picture. An angle of depression, remember, is an angle from a horizontal, but down. So it could be down like that, or it could be from a horizontal down the other direction. That's an angle of depression. So that's happening up here in this portion of the picture, straight out from that helicopter, but then looking down towards that building roof. That would be angle FLS. Angle FLS would be an angle of depression. All right, that's it for today. We will see you back in class. Thanks for watching.